Okay. Now, what the student put the văn phòng đào tạo in here? What's the name of this student? Okay, hiểu.
Mr. Toàn.
Toàn nhá.
Toàn đổi cái tài khoản em mà xài cái của Đàn Khói rồi.
Văn phòng đào tạo quốc tế Đoàn.
He's from the Youth Union. And he maybe
the youth unions of the OISP.
Yes. Maybe he forgot to change the email.
Okay, change the avatar. Okay, so we finished. So I practiced you about the tutorial today. So now, make sure you got okay. Now, you got the tutorial number 4A, 4B, and tutorial number 5. Yeah. Okay, now assume. Yeah, I checked that is the different symbol for each 2n. Yeah. Sorry, I have 3 dogs. So I do not really know what the dogs, yeah, she wants what the thing. So let me check a minute, yeah, to look after her. Yeah. What? Hey. Yeah. I do not really know what the dog, yeah, what she wants. So that is okay. Now, if we want to sketch for each 2n, so I change the symbol of the each 2n. That becomes to be this one. So step by step, when we substitute the value of n equal to -1, then this one equal to is -2. N equal to 0 equal to is 0. N equal to 1 okay. When you substitute the value of the index n. And then finally, yeah, you can work out for the result of each 2n. Okay? Is minus 2 is 0, is 2 is 4. Yeah. Given already. Okay, given already from the question. So you can take that one to sketch for the H2n. Okay, so from this result, you can see the original signal Hn is with six discrete time sample. But after when we do for this case, yeah, we take the H2n just only 3 sample. So this one is the ways the people would say we apply the decimation process. Decimation and interpolation. What in Vietnamese we say is decimation and interpolation. When we learn in the chapter 4, chapter 4. Decimation. No, we learned in chapter 3, sorry. Chapter 3. Decimation, in Vietnamese, we would say, what? Bát hành. Hành.
Yeah.
In the chapter 3, yeah. I did let you know already, yeah. Decimation is giảm mẫu. Interpolation is tăng mẫu. Do you still remember? Okay, in the chapter 3, yeah, we sketch a block diagrams and just very quick, yeah, we see the terminology decimation and interpolation. Giảm mẫu, tăng mẫu. From when we sketch for the H2n, you see, we can reduce half of the samples. Okay, so that way is the case we do for signal decimation. Okay, no problem with question 1. Okay, we do similar to other ways. Okay, now look at the question 2. No. Question 2. Okay, now look at the question 2. Quickly, okay, now quickly just let the students in the class knows about the process of your solution. Okay, just show the process of the solution. Or we can say, yeah, you can provide the block diagrams of the procedure, how we can work out for the solutions of question 2. Okay, Thanh. How? What is the process that you apply to this question to find out the solution?
The first one we will, I think the first step, we will calculate the omega for
Omega of what?
omega of we will calculate the frequency response.
Now, can you provide the block diagram or the flow chart? Okay. Okay, now step 1, step 2, step 3. How can you get the results or the given impulse response of the system in the frequency domain, and also given its end? How can you find out the output variant? What the first step you do for?
The first one, I will find out the omega of the H function. It
Of
is
the impulse,
of
the frequency response?
Yes. The
For
omega.
what?
Yes, it is of the frequency response.
For what? And for what? Now I have to remind you. Yeah? The same meanings when we write out the H omega or H J omega or H E J omega. Sorry. Okay. I have to remind you because depending on the author, when you read the books, okay, the author would use just write out H omega, even if it is a complex function. Or some author, they would write out H J omega. Or some other authors, they would write out H E power of J omega. All of them are the same meaning. Yeah? Okay. Now, what for you find out the omega of frequency response? And how? Tan, what for you have to find out the omega? What the specific omega you mean?
We had to find the omega to because we need to find the output function, and maybe
How can you find out the omega from the frequency response?
We use it's equal to the omega of the x function, the input function. It is pi over 2.
Yeah. Yes. And how can you work out for the output yn? Okay, the Viet. Where is the Viet? Viet.
I'm here, sir.
Okay. Now, how can you work out the solution for question 2? Just provide the procedure. Step 1, step 2, step 3.
I think the first step, we consider the input function xn equal to cos and transform to the eigenfunction
Yeah. How can we convert it into that is the form, yeah, to present for eigenfunctions of the case.
So present in eigenfunction xn is equal to is power of j multiplied with 0.5 omega of pi.
Say again. Is n equal to?
Xn is equal to if power 0.5 pi jn.
Yeah. And
the output of the
no. You have to provide a full. Yeah. Is n equal to?
xn is
Say again.
equal to e power with j omega n. Omega is equal to 0.5 pi.
Now, what the formula you have to use to convert the cosine function into the forms of e power of j omega? What the famous name of the formula? Do you still remember, Tan?
Euler.
Yeah, the Euler identity.
Yeah.
What the Euler identity? Okay, we can say that is the Euler formula or Euler identity. Okay, do you still remember the formula? Okay, so this is the Euler identity or formula. Okay, the first step, we apply the Euler identity to convert the cosine function into the form of e power of j omega. And then we apply the concept of eigenvalue of the system. Then we can work out for yn. Right? Okay, at the end of the chapter 4, yeah, we already talking about that is the eigen function or eigenvalues of the system. Okay, that means it's straightforward because some student, the answer is the first step, convert the Sn into the frequency domain by using the Fourier transform. And after that, taking the multiplications of the H omega and S omega. Finally, take the inverse Fourier transform to get the Sn. That one is correct also, but take a long way to go. Okay, for this particular case, we just directly use the Euler identity, converts the cosine function into the forms of e power of j omega. And then directly we can write out the yn. The yn equal to the Sn. In the case of Sn, we can present as an eigenfunction form, yeah? And multiply H omega. Okay? So that is the way to go. Any questions about question 2? No problem. Yeah.
Sorry, teacher. I have the Euler Identity cos A equal E plus E.
Oh, yeah. Sorry. Yeah. Plus. Okay.
Yeah.
Sorry. Yeah. You are right. Okay. This one minus we apply for what case? What case?
For
In the
sine,
case of the sine function,
sine function.
sin, yeah, sin A equal to e power of j omega,
Sure.
ja minus e minus ja. But the cosine function, this one is a plus. Okay, we take the average of this one. Okay, this is a cosine function, and minus in the case of the sine function. Okay. Any more questions? No? Okay. Okay, now question 2. Now let me check. E, J. Minus 2. Now, question 3. Linear times invariant system described by the I/O relation. Yn equal to that. Yn equal to Xn plus 2 Xn minus 1 plus Xn minus 2. So how can we work out for the Hn? What the impulse response Hn? Nguyễn Vĩnh Hảo. Hảo. But how can we determine the Hn in the case? Okay. Lê Minh Tiến. Where is the Lê Minh Tiến? Lê Minh Tiến.
Yes.
Okay. How can we find out the Hn? What the Hn should be?
HN, I think is
You should better using the basic definitions of the impulse response. Do you still remember what the basics definitions of the impulse response?
It's from the is equal to 1 if n equal to 0.
No.
The basic
Okay.
is
Okay, Trần Quốc Khang. Where is Khang? Is Khang there? Khang. Trung. Trà Quốc Khang. Trà Quốc Khang.
Yeah, I'm here.
Turn on the camera.
Yeah, I cannot turn on the camera
Why?
because I have some problem with my cam.
Problem with the camera? What the problem?
Yes. It's my computer is I cannot fix my cam on my computer, so I cannot open that.
What kind of the machines are you using? You use a laptop,
Dell.
desktop, or what?
Laptop.
Laptop. But no
Yeah.
camera in your laptop, or?
I'm not fixing that because it has
Okay,
some
can
trouble with that.
you use a mobile phone? Mobile phone. Log in also with the mobile phone to the meeting. I want to see you. Okay, you absent several times, yeah? What a problem, Khang? You absent many times up to now. Huh? What a problem? Just let me know.
Nothing, sir. Nothing. Okay.
No problem? But why you absent many times? Okay, anyway, try to turn on the camera, yeah? Use your
Yes.
mobile phone and let me see your photos. Okay, Bá Thành.
Yes,
Do
sir.
it, yeah, Khang. Do it. I want to see you, Khang. Bá Thành. Okay, now, what's the action?
Yes, is equal to the y the y divided by the expression.
What do
We
you say?
use
Action equal to?
yn divided by xn.
This one? This one you mean?
No, no, sir. We need to transfer the output and the input into the frequency response, and then we'll take the division.
Say again.
First, we need to change the input, the y and the x function into the frequency response, and then we.
You mean this?
Yes.
You mean this way?
Yes. First,
And after that, we take the -1. Okay, inverse.
Yes.
Inverse Fourier transform. And then to get the action.
Yes.
This one would be a long way to go. Now, say again, what the basic definitions of the impulse response time?
It is the output of the impulse function.
What?
It is the output of the impulse response is the output of the impulse function.
Okay.
Yes.
So we can apply to this case directly. Yeah, we can write down the action. Okay. How about you, Việt? Hoàng Việt?
Yes, sir.
Now, what the action when we apply the basic definitions of the impulse response? Who knows? Any of you? Okay. Now, Chào Quốc Khang, turn on. Let me see your photos again. Khang.
Can you see my face?
Okay. Can I see your whole face? Khang.
Yes.
Okay. So, why you did absence many times? Oh, Khang rời khỏi cuộc họp. Okay, anyway. You have a solution, Việt? That is very much easy when we apply the basic definitions of the impulse response. Okay. Yeah. I see now. Now, where is Nguyễn Kim? Where are you, Kim? Kim.
I'm here, sir.
Okay. Now, what the action? When we apply the basic definitions of the impulse response.
I haven't figured it out yet.
So I'm maybe I have the answer. I think that first we because this is the linear time inference system, and we will take the response of each component. This means xn is we will transfer it to the impulse function, and then sum all of them. We will get the it's.
So that means what the action? What the action should be?
Yes.
Based on the definitions of the impulse response. I remind you again, that is the impulse response of a system is the output when the input is the delta function. Okay, so that's also mean we can directly apply to the IOs. This is the IOs. It is the IO's relation or IO equation. Okay, automatically, when you remember the basic definitions of the impulse response, you can directly write out the action easily. Just change the yn to the xn and the xn to the delta function. Okay, So based on the IO relation, we can directly write down the xn equal to delta n plus 2 delta n minus 1 plus delta n minus 2. Easy, huh? Very much comfortable. Yeah, we can see for. Okay. Because, yeah, I just connect my computer to, that is the TV big screen next to my computer. So that is, so I look at this. Okay. So all of you should better turn on the camera. All of you. Okay. So because we have that is a small number of students, so the traffic is not much busy. So you can turn on. Then, yeah, we can face to face, looking each other quickly. Okay. All right. No problem. To the question 3. Now, Tan, is this a stable system? Tan,
Yes, sir.
why? You have to explain, yeah? When you say yes or no, you have to explain why your decisions about that.
Because it's because the total value of sorry.
You heard about the FIR and IIR system? Yeah, I did let you know already.
Yes, finite impulse
Okay.
response.
We have two groups of the system, namely the finite impulse response and infinite impulse response. Okay. So, and normally, now try to take notes. Yeah, try to take notes. And since then, yeah, you can easy to remember the concept of the FIR or IIR. We can use quite a lot, very much popular later on. Okay, so I expect you should better remember the basic concepts related to it is the finite impulse response. So normally from the IO equation, we do not have any recursive terms or recursive or feedback terms. Whereas the IIR system, we always get the recursive or feedback terms. Okay? In Vietnamese, we would say that is because when I deliver the significant, the Q notes related to the issues, I got no feedback from you, so I do not really know that where you have a good concentration or understand what I mean. So not. Catch up with what I explained to you. So this. Try to feedback to me, yeah. Try to feedback to me anyway. Yeah, I can check the communication link. I can check your understanding. Okay, and also you would get very good concentrations as well. That is the reason why I always ask you every time when I raise a question or explained to you about that is the specific issue, you should better respond to me. Say something, so that is okay.
Sorry, teacher.
Who got the slides in hand? Hard copies of slides in hand. Raise your hand, please.
I use notebook to take notes, sir, and I watch
Take
the
notes.
slide
Okay.
on laptop.
How about you, Hill? You have any notes? Okay, sorry. Okay, sorry. That is vocal interrupted. Okay, so or I let you know that is the explanation in Vietnamese, so you can easy to remember. Yeah, the FIR system always stable, because no recursive terms. Whereas the IIR with the poles, so we have to consider or we have to examine whether it is stable or not. But the case of the FIR always stable. Tức là đối với bộ lọc fear thì nó luôn luôn ổn định. Tại vì nó không có cực, không có cái recursive, không có cái thành phần hồi tiếp. Thành phần hồi tiếp là gì? Thành phần hồi tiếp là en minus 1 minus 2 minus 3 and so on. So that one we say the recursive terms, because that one still depends on the yn. Okay, so no recursive term, the system always stable for the fear. But the IIR has poles. Tức là cái IIR system có các cái cực do các cái thành phần hồi tiếp á, nó tạo ra cực. Khi mà chúng ta chuyển đổi nó qua cái miền omega hay là miền Z hay là miền S. S thì không apply đây, tại vì đây là rời rạc nhé, discrete time. So just the omega or the Z domain. So, and the IIR has poles, so we have to examine whether it is stable or not. Tại vì nó có cực. nó có cực. Vì vậy nên chúng ta phải xem xét xem nó có ổn định hay không. But the case of FIR always stable. So when we look at the function, the IO equation, you can easy to recognize it is the FIR system or FIR filter. So that means no pose. The system always stable. Okay. Now we move to the C. Determine HE power of j omega. Use trigonometric identity obtains the expressions of HE j omega. So that one is no problem. Yeah, you can practice. You can practice on that. Okay. So number 4. Oh, sorry. Now, what the number 4? Number 4, given the input is 0, then pass through the system, we got the y0. Now the question, find the response of the system to the signal is 1n. Okay? So that means, okay, I let you know, because after this, I expect all of you have to work out for the first minor mid exams, okay, for about 45 minutes and submit your paper to me. Yeah, since then I would know that is what the percentage of your understanding. Okay, that is the way. Yeah, I can get the feedback. Now I show you the way to go. Yeah, first you should better find out the relationship of x0 and x1. Try to take notes. Yeah, I will ask you to provide the solution for this question as well. So the first step, try to find out the relationship between x0 and x1. When you know, or when you describe the x1 and is the linear combination of x0, then you can apply to the case. Find out the response of the system to the x1n. All right? This is, bear in your mind, this is a stable LTI system. And to the B, you find out the impulse response section of the system. Okay. Right? Now, identity obtain the expressions. Okay. Now the question 3 and question 4. Okay. So, okay. Now, this is I call the first minor mid exams. Okay. I like to check your understanding, and also I want to get the feedback. Yeah. Whether how many percent you understand the lecture. I already let you know the ways to do for question 3 and question 4. Okay. Now, I let you spend 45 minutes. 45 minutes. Yeah. Now is 8:05 a.m. So that means 45 minutes you have to submit as 8:50. 8:50 you submit to Tan. Okay, all of you submit your paper to Tan, and Tan will collect all of the submission and put into the zip or RAW files. Compress all of the submission and just send one